Hello student, the question says electrical appliances with metallic bodies, example heaters, presses, etc. have 3-pin connections, whereas electric bulb has a 2-pin connection. 3-pin connection reduces heating of connecting cables. So let us try to answer this. First, the third pin that we generally connect is also used for earthing purpose. What is this earthing purpose? Let us see it. Suppose let us take any appliances that we have. So let us say this is the outer casing. And inside this, let us assume we have our entire circuit on a circuit board. So imagine that we have a circuit board inside and all our electrical things are inside this. Now, in two plugs that we use, so there will be one is called live wire and another one is called neutral wire. So let us assume one of them is live wire and another one is neutral wire, and current is coming and going into the circuit. So this is how my current is traveling and going into the circuit. And let us say this is the entire circuit I will represent with a simple resistor. And another wire would be going into this neutral wire. So the current would be traveling in this way. Current would be traveling through our circuit. And the current would be traveling. And this is a continuous circuit system, like continuous loop system, where current travels in this direction and leaves from one wire. Current enters from one wire, leaves from one wire. Then you might wonder, only two wires are enough for this entire process, right? But you know, these electrical systems would be very, very complicated. Sometimes what happens is that generally the body of the device does not touch the electrical system. Even this wire also would be insulated. You know that our regular wire is also insulated. Don't take this diagram to scale. You might wonder, we never have a wire of this much thickness. This just to explain. Okay, even this wire is also insulated. But sometimes what happens is that the outer casing might occasionally touch the main board, like whatever is the electrical system. This outer casing is only to protect this main board. So sometimes there could be some touching that could happen. That means a part of the current or this board might touch our outer casing. Then what happens when current flows through this? And let us say, even if it touches also, it is fine. Let us say you are standing here and you are touching this with your hand. Don't tell me this is not human. Okay. So let us assume you are standing here and you are touching the outer casing. Now what happens? The current will flow. The current will flow as it is in this circuit. Not only that, a part of the current would go into the body of this circuit, and from the body it will flow through you and it will flow to the ground. Because this is also a circuit got completed, right? And it is actually very dangerous to us, and you might get a very big shock if you touch in this direction, if you touch it in this way. So to prevent this disaster from happening, because with wear and tear, these kind of disasters can happen, especially if you have metallic bodies. If you have insulated bodies completely, no problem. To prevent the disaster from happening, we will take a third connection in this wire only. There will be another big connection, which is also called earthing. So there will be a wire from the body of this. Literally, it will be coming from the body of the circuit and it will be going through this. And through this earth wire, if you go and see, it will eventually be somewhere close to our home only. It will be buried under the ground. That means this earth wire is playing the role of you. Understood? It is playing your role. Suppose you are not there. Got it? And somehow there is some connection happened with the body. So rather than it is flowing through you, the current would travel through the body of this, and eventually it would travel into this earth wire, and it will eventually travel into the ground. So rather than the current flowing through you, it will travel through the earth wire and flowing through the ground. Suppose let us assume there is earth wire connection and still you touched it. Then you might ask, why can't the current travel simultaneously through the earth wire and simultaneously through your body also? Actually, it could happen. So what we do is we design this earth wire with least resistance. So since this earth wire has very little resistance, and our human body has high resistance. So if two paths are available, most of the current most of the current goes through this earth wire only. Very little current would go through our human body, so most of the current would actually go through the earth wire. Even in this case also you will get a shock, but it won't be that high because most of the current is going through the earth wire. So this is the reason, if the bodies are made up of metals, if these bodies are made up of metals, generally we need earth wire. And if you notice the 3-pin plug, the earth plug would be very large and the other two would be slightly smaller. The reason this design is chosen, because first, to ensure that we plugged this one, and this would be thicker also. So this design is selected so that you cannot place them unless you first place the earth wire. Okay, this will be lengthier also. First the earth wire would enter the plug, then the remaining two that will enter the plug. That is one reason. Another one, if the area of cross section is very large, we know resistance equals to rho L by E. If area decreases, if area increases, the resistance decreases. So we want the earth wire to have least resistance. That is another reason why the earth wire is thicker. So two reasons, and one more is that it is lengthier also, and it is thicker. If it is thicker, by mistake also you cannot insert this earth wire into these two things. You can only insert that earth wire into the thicker hole that is present at the top of these two. So the reason is that, if I need to write the reason, so thicker wire has least resistance, has least resistance. And another one is that length ensures that earth wire is plugged in first. Earth wire is plugged in first. And like thickness also ensures that we don't plug it in other plugs. We do not plug it in other plugs. So this is the reason why this earth wire is thicker, and this is the entire mechanism of it. So he has given earth appliances with metallic bodies. Example, heaters and presses, etc. have 3-pin connection, whereas the electric bulb has a 2-pin connection. Think about this. In an electrical bulb, we have only one wire, and the entire system, outer body, is insulated, and this is made up of a material which by default does not conduct that much electricity. So even let us say somehow some connection made between the body and this main circuit, this outer body is such a body that no current would flow through it. Even in your laptops, not laptops actually, even in your mobile phones or something like that, the outer bodies are created in such a way that even if any mishap happens also, no current would flow through the outer bodies. So that's why where the outer shells are generally made up of insulating materials, we use 2-pin plugs. And where most amount of the current generally doesn't flow, we use 2-pin plugs. But if you take very large power consuming devices, we prefer 3-pin plugs for safety, where the outer body is metallic, like laptops, air conditioners, or ovens. We need 3-pin plugs. So electrical appliances with metallic bodies have 3-pin connections, whereas electric bulb has 2-pin connections. This is true. 3-pin connections reduce heating of the connecting table. No, that is not the reason. They do not reduce the heating of the connecting table. So assertion is correct, but reason is false. Connections reduce heating of connection table. There is nothing like it reduce heating of connecting table. Hope you understood how this entire mechanism works. Thank you.